Hello folks, this is Roby Hyde, and in this video we're going to be catting up the Titan4M in Onshape. One of the nice things I like about the 4M is it's a little bit harder of a part, and it does require you to kind of think out of the box a little bit, although it's not as hard as you think it's going to be. So let's dive in and take a look at how to CAD this up. If we look at the drawing, we can see it's a simple triangle to start with. And oftentimes, one of the hardest things is to figure out where should the origin of this sketch be that I'm going to create in Onshape. Should it be dead center of the part, like we've been doing in some of our previous drawings, or perhaps maybe it's on one of these corners. And oftentimes, you can tell based on the dimensions that they're using where the origin would be most helpful. And in this case, we see both the vertical and horizontal dimensions being derived from this midpoint right here on the baseline. So I'm going to use that as my origin. So we've got a 2-inch tall triangle, 1.15, a length from the origin. So that's much bigger than 1.15 across the entire bottom, but each side is 1.15. And then there's some fillets on the corners. Let's go ahead and create this in Onshape. I click on Onshape, I hit Create. I'm going to create a new document, and I'm going to call this the Titan4M. Awesome. And now that I see my document, I want to create a new sketch, and I want to sketch on this top plane. And I'm going to lock into this top plane, get rid of the planes overall with a P, and now I'm ready to draw. So I want to start with a line tool. Here's my origin here, and I know that I can go up 2 inches to create the start of that triangle. So that's fine. And then we've also got a side line here coming out sideways to the left, and that's 1.15. Excellent. Now you'll notice I haven't escaped, so I'm still in the line tool, so I'll just go ahead and connect those 2 points. And at this point, you might be thinking, well, let's just mirror that, and we certainly could. It's just as easy to draw it, though. It's a pretty simple shape here, so I'm just going to come over here and say, let's do another one of those, 1.15, and then just come up here and connect it. Great. Now this center line here, I really don't want that to be a feature in my part, so I'm going to go ahead and turn that into a construction line. And if we zoom in a little bit here, this is what our triangle looks like now. Let me line this up a little bit just so it looks better. Excellent. And then if we go back over here, again, the only thing left here, first off, we have to extrude it down 0.75, and then we got 50 thou fillets. All right. So I'm going to say OK to the sketch, and now I want to extrude, and what I want to extrude is, I don't want to extrude that or that. I want to extrude the sketch. Solid. There we go. And I want to extrude this down, so if I rotate this in 3D space, it's by default going up, and I want to go down 0.75, like that. I'll accept that, and then I want to go ahead and put fillets on these corners. I've got 3 corners, 1, 2, and 3, and those are 50 thou fillets, which that is a correct number there. And so we can now see what those fillets look like. A little bit of a rounded corner there. Excellent. So now we have finished the first page of our drawing, and all of those dimensions are accurate. The second page introduces us to these holes, which we've gotten pretty good at. Our holes, in this case, they're more 1032 threaded holes. They go down 375 minimum, and they also have a chamfer. So we kind of know how to do this already. And they've given us the location of each one of these hole centers. So let's go ahead and put those in. This top one is on the center line, but it's 1.637 up. So I'm going to go ahead and create a sketch on this top plane. I'm going to lock into the top plane, and I'm going to draw a, actually, I'm going to draw a point. And as I draw up from the center line, or from my origin, we can see that I get that nice orange marker. And so I'm just going to put that there, and I'm going to dimension this. And I can dimension this. Let's see, let me move it way out here. And what was that dimension? 1.637. Okay, so that's where that hole goes. And then we've got two more holes. Um, this one is 828 over, and this is interesting. Instead of saying how far over it is from the origin, they're spacing it from the other one. We'll do the math here, but I'm pretty sure those are equidistant from the origin, so this should also be 828, but we'll check it out. And then we also are coming up 1.89, so we have to remember that. Okay, so let me go ahead and put those in. I'm going to use our point tool. I'm just going to place a point here and a point horizontal to this point over here somewhere. So I'm going to follow my guide and click that into place. Okay, and now I see that those, in fact, are horizontally constrained. Let's go ahead and space this out with the dimension tool. I'm going to dimension this from the bottom, and that is a distance of 189. Okay, so both of those are now at the correct height. And then from a left to right perspective, I want to dimension this from here to here. And notice when I dimension this, I can, oops, yeah, got the dimension tool selected. From there to there, that's a straight line to the origin. That's not really what I'm looking for, right? You can see here that as I move the cursor around, I can actually get the horizontal distance from the center line to that point as well. So that's what I'm interested in. And that center line is 0.828. Great. Now, if we make this other one 0.828, we should see, yep, there we go, 0.828. And then in the drawing, they're saying that that total distance should be 1656, which a good way to do that is, obviously you could do the math, but perhaps an easier way to do it would be to dimension between these two, and you can enter that in down here. Now, it also kind of puts this additional dimension in gray because this is a derived dimension. In other words, if I change this dimension, then it would not agree with these two dimensions. So these two take priority over this derived dimension. That is the correct dimension. Excellent. So now we have all three holes in the correct place. It's time for us to make the actual holes. So we'll save our sketch, go to our hole tool, and in this case, we want a 1032 class 2B fit, and I want a chamfer of 0.211, 90-degree chamfer on that countersink. And we're going to go down 0.65 again and have the tap depth be 0.45. Still leaves me about 6 threads at the bottom there. Plenty of room for us to put a tap down 0.375 to get the screws in that far. Okay, now I just need to select where we're going to put those screw holes. And that looks good. Say okay. So now we have the screw holes in place. So we've got those all defined correctly, 3 holes all the same with a 0.211 chamfer, and all the dimensions are correct. Let's move on to page 3. Oh my goodness, look at all the complexity here on page 3. Well, again, don't get too overwhelmed because this is actually quite straightforward. You just got to take it one little piece at a time. So first off, in this page 3, we see that there is a section, and that's highlighted down here, So if we put our eyes down inside of this cavity and we kind of look upwards, we'll kind of see this shape, which makes sense. These cutouts on the side are kind of interesting. They're curved, but from our cutaway view on section A here, they look like square cutouts, but you can kind of see with these dotted lines that they come in farther in some cases than where A is. And we also see that we've got a threaded hole straight ahead of us, and that's what that looks like. But other than that, this is most useful for telling us how deep this large pocket in the middle is, and this goes down 0.65. So why don't we start with this big pocket in the middle? This is using the same kind of trick that we've used before, where we've got a wall thickness of 0.174. So we can do an offset to create this inner triangle, if you will. So I'm going to come over here. I'm going to create a new sketch on this top plane, lock it in, and now I'm going to come over here and say, let's do an offset. And I want to do an offset of the entire part here. And I want to come in a distance of 174. Instead of going outwards, I want to come in a distance of 174. Click, oops, 0.174. 0.174. Let's try that again. There we go. So there's our inner triangle, and it does have a rather large radius on these corners here. So a 189 radius, and this what this means is they'll allow plus or minus 30 thou on this dimension. Not quite sure why they put that in here. Since we're CADing this, we can always make it perfect. If we were actually manufacturing this part, then that might be more important to me if I don't have the right size end mill or something like that to make this 0.189 corner. But since we're in CAD, we can always make things just perfect. And so we're going to make 189 radius points on our triangle here. So let's go in here, the fillets. So I'm going to do this in the sketch still. I'm going to leave the sketch going because we've got lots of other things to sketch. But I can put fillets in a sketch, and so I can select those two. And the distance that I want to specify here is 0.189. Okay, so there's our 189, and I want to do the same thing on these other two. Right, so I'm going to select that. It's already remembering my 0.189. That looks good. And then I want to do the last one down here on those two. Again, 0.189. Excellent. So now we can see that we've got that inner triangle, and we need to go ahead and make that, extend that downward 0.65, but we're going to save that. We'll do that extrusion later. Okay. All right, so we've got that first thing out of the way. Let's see, what shall we tackle next? We've already got these circles here, but you notice around the screw holes, there's these outer edges. Let's go ahead and put those in place. They're giving us some really good descriptive text here. So these bottom two holes are different than this one up here. These bottom two are 3/7/8 diameter, and they're tangent to both sides of the triangle. They're not actually centered on the screw hole. So we don't want to build off that screw hole. We want to basically make a circle that's tangent to both sides and not worry about the screw hole. All right, so let's go do that. I'm going to come up here to my center point circle, and I'm going to just come over here somewhere and make a 3/7/8 diameter circle, 0.378. So to make it tangent, I'm going to use constraints. Right? I've got a tangent constraint here, and I want to say this circle is tangent to this line, and it's also tangent to this line, and it lines itself up. Excellent. Let's do that on the other side. Again, a center point circle somewhere over here, and this is going to be 0.378, and tangent to that point and this line here. Great. Now in the drawings, it said that it's not centered on the bolt hole, but it really looks like it's centered on the bolt hole. Let's zoom in and find out if it's really centered on that bolt hole. Now look at that. It is actually off center a little bit. There's the center of our circle we just made, and there's the bolt hole circle center. Interesting. Okay. But this gives us a nice tangent circle that is going to be lined up just perfect to our sides there. Now the one on top is just a little bit different. It is still a 378 diameter, but it's actually using the bolt hole circle as its center point instead of just being tangent. So we do use the bolt hole here. So another center point circle. And I'm going to zoom in to make sure I get the center of my bolt hole circle and come out 0.378. Great. And we immediately see that it's too big. It's not tangent to these lines, but that's what they're calling for. Okay. All right. So if we look now at our sketch, we've gotten these things taken care of. Really the only thing left are these big carved out arcs on the sides of our part. So here's where we need to think outside the box a little bit. What is carving these arcs is a large diameter circle that is centered way out here. Okay, it's a couple inches out and a couple inches up, but that center of the circle is where this arc is coming from. So let's start by putting that point in place. So I'm going to come over here. I'm going to grab my point. I still have my sketch going, right? We got this sketch going for all this stuff. And now that I've got a point out there, I'm just going to hit D and dimension that. Dimensioning it from the origin over here, I want to move my cursor around till I get a vertical representation, and that is 1.949. And then we're going to do the same thing, dimension it from the origin, except we're going to go upwards this time, and it changes into a lateral measurement, and that's 2.222. Okay, so our point is way out here, and that point is the center not only of an arc, but also an arc is just a part of a larger circle. So I can do a center point circle now and draw this out. The radius of this circle is 2 inches, so I'm going to say this is a 4-inch diameter circle. And there we can see it carving that part of our part out. Excellent. Now I'm not going to turn this into a construction line because this actually is a feature in our part. So I want to keep that as a solid line. And now the trick is, how do we get this onto the other two sides, right? Because we've got the same thing here and here. And really the only clue they've given us is this point in the middle here, the center of slot rotation. Okay, so this is really just a circular pattern of 3 circles, right? Nothing different than what we did in the Titan4M. It's a circular pattern of a sketched item. So we just need to know the axis of our axis of our rotation, which is on the center line, 0.667 up. Let's go ahead and put that point in place. Grab a point, put it on the center line somewhere, hit D for dimension, dimension that to 0.667. Excellent. So now that we've got that in place, how do we rotate this circle around a circular pattern defined by that axis? Well, the last time we did a pattern, we were not in the sketch tool. There is a pattern inside of the sketch tool here. So let's use this, right? We're going to stay in the sketch and we're going to do a circular pattern. And when you say circular pattern, the only thing that you need to do is select what you want to pattern. So in this case, if I select the circle, it tells me, or it gives me an option to change how many of these I want, right? So if I want 5 circles, I can do that, but I really only want 3 circles. And I want to make sure that the axis of rotation is on our point that we created here. And here we can see that this axis of rotation, this big gray line, is set on our part origin down here. So let's move that. I'm just going to pick it up and move it. And I'm going to get it to lock in right there. And now, sure enough, we see 3 circles beautifully arranged around our part, carving out the proper amount on each side. Beautiful. At this point, we finally have enough for us to close this sketch out because we've got everything we need inside the sketch now to make the rest of this part. So what do we do first? Well, first thing I want to do is I want to start putting some extrusions in place. So let's start with this big thing in the middle. Let's extrude that down. And I need to not only, let's see, I need to remove from the solid that part. And then I also want to zoom in a little bit and make sure we get this part. And then the same thing on these corners here, that part and that part. Okay. And the depth of this center pocket is 0.65. So we want to go down 0.65 here. Great. So we're removing material from the solid down to a depth of 0.65, which is pretty much near the bottom, right? We've only got 10 thou left over between the bottom of this pocket and the bottom of our part now. But I'll go ahead and say okay to that, and we can see that deep pocket. All right, let's go ahead and take care of these steps on the corners. So I'll extrude these steps. Boom, and those go downward and also to a depth of 0.375. And we are removing material. Okay, so that's what those look like. Okay, and now the last thing to extrude are these big circles. So these big circles, since we drew them as part of our sketch, they're on the top of our part. And that's clearly not where we want these slots to be. But fortunately, our extrusion tool is really smart. So if we go into the extrusion, we're going to say that we want to remove some material from our part. And I want to not remove that whole thing, right? Because that's actually leaving the part that we care about in there. So let's get rid of that. Instead, I want this little sliver, right? That's what we want it to cut out. Right here, it's showing it's cutting it out of the whole face, but let's worry about that in a second. All right, so we want those 3 sides cut out. But here's where we get some options that are going to be super powerful here. If we look at the drawing and this section, we're only supposed to come down 0.375, and then the thickness of this cut is 0.125. All right, so how are we going to do that? Over here, we've got a starting offset. The starting offset is down 0.375. Okay, and that is only a depth of 0.125. Okay, now in this case, it starts at 0.375 and the depth is 0.125, but is that going in the right direction? If we look over here, we can see that the bottom of the carving is in line with the step, right? The steps are down 375, and so is this. So we don't want to go any lower than 375, which means we simply need to reverse the direction of our depth, right? And so now our slots are coming upwards from a depth of 0.375. That looks awesome. I'm going to save that. And I'm also going to hide our sketch. Excellent. So now this is starting to look really good. We've got a part that's got carved edges, steps, and a big pocket in the middle. The last thing to do is to simply add in the standard edge breaks of 10 thou. So looks like we've got edge breaks on the outside and on the inside, but not on the steps or on the slots. But we will also do it on the bottom. So I'm going to come up here, pick our chamfer tool, edge break that with our tangent propagation, edge break that, and edge break the bottom. And that goes all the way around. Now, the one place it does not catch is this little line right here because it's not tangent. So you got to watch for things that are not tangent. Let's add that in there and it will get that now. Excellent. So the one thing about the 4M is that this top arc up here is not tangent, which means it looks a little bit different than these other two tangent lines. So just something you can always tell a 4M that's been catted correctly based on how one of these is not tangent. Excellent. Anyway, that is the Titan 4M, and I appreciate you guys spending the time to watch this. And until next time, I'll see you later.